Hello world, welcome back to this tutorial on writing a programming language compiler. I don't think this video is going to be particularly interesting because today we will just have to go through some diligence work. We will write a lot of helper classes that we will need to represent the abstract syntax tree on the heap. The big picture idea is if you have some code like a equals b plus c, if a bigger than b, I don't know, print hello, something like that. Then we need some way of representing that on the heap. So we will need some data structure for these so-called statements. We will need some base class for statements. And then some derived classes like an assignment, an if then else, a while loop, and some more stuff. And then we can represent this whole code as a list of such statements. Okay, so then we will have a block which will correspond to something like a list of statements. And then we just need to talk about these things like, what would be the attributes of an if then else? Well, an if then else, let's say, an if then else has a condition, and if that condition is evaluates to true, then the then case is executed. Otherwise, the else case is executed. So an if then else, for example, will need something like a condition, which itself can be different things. Like you could have multiple conditions combined with an and or an or. So we will need some base class, subclass like boolean expression. Okay, and this condition needs to be of that type, some boolean expression, and then boolean expression will have subclasses like an and, an or, and so on. And it will also have comparisons like greater than, less than, equal to, stuff like that. We will need a class for arithmetic expressions like b plus c. So then this will have subclasses like a plus, a minus, a constant, like a equals 5, for example. You need some way to represent a constant. So an if then else will have a boolean expression, as I said, and then it will also have a block for the then case and a block for the else case. Okay, that would be an if then else. We really just need to get through all these classes, like for the arithmetic expressions, the boolean expressions, some more helper classes. And yeah, then in the end we will write a few little programs directly on the heap. You know, the main function will just instantiate some of them and build a program out of them and run them. Yeah, let's go. I will use one header file for the base classes and corresponding CPP file. Then we will need something for statements. We will need boolean expressions. We will need relational expressions. And arithmetic expressions. Okay, and yeah, while we're at it, let's also make something for location values. Okay, and now let's run Kate, text editor. Okay, and yeah, just for testing, I will also make a main CPP. But we won't need that one. We will need a completely different one for the final compiler. This is just to start running some tests. And a makefile. Okay, so in the base classes, so here I want to have all the base classes for arithmetic expressions, boolean expressions, relational expressions, and statements. Start with an include guard. Well, when we want to test this stuff, for now I don't want to generate assembler code. I will just I just want to have some way of executing that stuff. You know, I want to get the abstract syntax tree and then run that abstract syntax tree directly without compiling it to some assembler code first. So because of that, I will make a purely virtual method called execute. Okay. Yeah, okay. You know, in my code, I always tend to violate the rule of 3 here. You know, if you have a constructor and a destructor, you usually should have a copy constructor, but since I'm using this stuff just to build something on the heap and then only work with pointers, yeah, I just don't need a copy constructor, because I never make copies of these objects. I just move pointers around, so that's why I'm doing it this way. It's not a boolean expression. Okay, for a boolean expression, I will need to run it at directly after parsing it. I will need a bool function for evaluating this. Also purely virtual, or abstract, as you would call it in different programming languages. Then we have relational expressions. Yeah, relational expressions is something like a less than b, or something like that. So a relational expression will typically have two arithmetic expressions and then compare them in some way. But the thing that you will get back from that comparison is also a boolean. So yeah, a relational expression is a boolean expression. So I will derive that here. Okay, this is already virtual because it's derived. And yeah, we will also have an evaluate method for them, but yeah, that method is already declared up here, so I don't need to declare it down here again. And when I use an arithmetic expression at runtime, I will need a function also for evaluating the arithmetic expression, but it will return an integer now. Also purely virtual or abstract, as you would call it in Java or C# or something. Okay. Okay, so this is the stuff for the base classes, and yeah, as you can already imagine, these other files will then contain all the derived classes from these base classes here. Okay, I had also created this L value here. I will also make a class for that. yeah, now location values are values where you can write something, like a variable, for example, but you can also read from location values. So here I will have some function for setting. And a method for getting the value from that location. Okay. Oh, I forgot to mention a location value is of course also an arithmetic expression, so I will derive this from arithmetic expression because well, this get method can also be used for the evaluation of that arithmetic expression. Now, as I said, all these helper classes are very similar to each other, and because of that, I often use preprocessor macros to generate them. So the classes for boolean expressions would be something like boolean expression AND. So something that allows you to combine two boolean expressions with an AND. Yeah, an AND of course needs two Boolean expressions as parameters. Okay. Now, this Boolean expression for AND would then have two fields for storing these two parameters, right? And the idea here is that, well, the constructor would just store these values like this, and yeah, the destructor would just delete them, and yeah, the evaluation method will evaluate both sides like this, and then combine the results of both sides with an AND, which makes sense for AND. And yeah, basically the same thing is what you would do with with the OR, you know, you would have them like this, and it would basically be the same class, except that it has a different name and it uses a different operator between them. And it's also the same idea when you have these arithmetic expressions, like an arithmetic expression for plus. Derived from arithmetic expression, it would basically be the same idea. You know, it would be like this. You have two arithmetic expressions, which you take from the constructor, and you delete them in the destructor. And the only thing that's different here is that you just combine the results of the both L and R sides here with a different primitive. You know, up here it's an or an and here it's just a plus. So it's always basically the same idea. And yeah, that's why I like to generate all this stuff with macros. So something like binary operation needs a type, a name, a base type, and yeah, maybe the return type, and the actual operation. Okay, so instead of the actual name here, we'll put the name here. Okay, so what's a return type? Evaluate, override, and here we just put the operation. Okay, so now we can just define our arithmetic expression plus, for example, just as arithmetic expression plus. The base type is arithmetic expression. The return type is an int, and the operation is a plus. Okay, so we might just put this now into arithmetic expression. Okay, this already defines the binary operations, at least the typical ones. Okay, and yeah, let's just do the same thing for the boolean expressions. Okay. Now the third typical Boolean expression that you would have is for not, but yeah, a not doesn't have two sub-expressions, so the not is a so-called unary operation, not a binary operation. So we will need another macro here for a unary operation. Now we only have one sub-expression. So we only store that, we only delete that, and then we apply the operation to the result of that inner call. Okay. So for a Boolean expression, not, okay, now we have a unary operation for not, which is derived from Boolean expression. It returns a bool by applying the not to the sub-expression. Yeah, for arithmetic expressions we might do a similar thing. Where we would just a multiplication with a minus. You know, you might write something like minus open parenthesis something close parenthesis, and then of course that is a shorthand for 0 minus that, and yeah, it depends a bit how you want to represent it, because of course you could just represent that as 0 minus the sub-expression, but yeah, we could also represent it like that, where we have a unary operation for negating an arithmetic expression by just applying minus to it. I think if we could also do 0 minus, but I think it should work both ways. Okay. Yeah, right now we are really not using the CPP files. I'm wondering if I should have just omitted them, because we generate all the code also in the header files. It's not exactly great style, but yeah, I think I will just accept that. Okay. Yeah, the relational expressions are all binary operations. Let's see. Relational expression less than is derived from relational expression. The evaluate function returns a boolean by applying a less than between its two. Wait, that doesn't work. Because so far we've had the situation that the types of these fields was always the same type as the base type, but yeah, now in this case we have a different situation, because relational expressions will have arithmetic expressions on the left and the right, but be derived from Boolean expression. So yeah, I think I will have something like a content type. Okay. Now, of course, we will need to put this here also. Okay, and this is derived from relational expression, but the sub-expressions are arithmetic expressions. Okay. Relational expressions for equal, unequal, less than, greater than, less or equal, greater or equal. Okay. Less than, greater than, less or equal, greater or equal. Okay. Okay. Now, now we also need a class for constant arithmetic expressions, like 5, for example. So we will just store a value that we will have read. Yeah. This class is just too different from the other classes, so I will just handwrite this class. So of course a constant value, yeah, this will just get its value from its from the parameter in the constructor, store it, and then just return it when we are asking for it. Yeah, we could have a similar thing for true and false in the boolean expressions. True doesn't have any parameter because true is just always true. So this will just always return true. And similarly for false. I just realized the constructors, of course, need to call the base constructor. Yeah, the boolean expressions look pretty good already. Arithmetic expressions look pretty good already. Relational expressions look pretty good already. Yeah, let's look at L values. Let's have just for variables. And yeah, a location value for now just has a name. A variable just has a name. I don't know. I don't really like this thing that location value is derived from arithmetic expressions. So it will have it needs to have an evaluate method, but also this get here, which really just does the same thing. I will just throw this out and say evaluate is the one that we will be using for these location values. Here we will store the name. Yeah, we could have more things like arrays or something, which could then have an additional parameter for an arithmetic expression that would define the index we are talking about. But for now I will just leave it like this. And yeah, with the stuff that we have right now, we cannot fill these methods yet. We will need to talk about them a bit later. So yeah, let's finally come to the statements. And yeah, one classical statement is of course the block. Which, yeah, of course has a list of statements, or maybe not a list, let's use a vector. So in the destructor of this, we will just delete all the statements. Okay. And yeah, to execute a block, we just execute all the statements one after the other. Of course, this doesn't allow for something like a goto, but yeah, with the statements that I have in mind right now, a goto won't be necessary. So to execute a block of statements, we execute every statement one after the other. Okay. Now, with the statements, they are usually so different that it doesn't make that much sense to generate these classes with macros. So, yeah, what else do we have? We might have something like a write, which writes a string. Here we also have a string. Okay. Okay. Yeah, write just writes its text. Okay, now let's come to some more interesting things like a while. A while will have a boolean expression which says, yeah, while this condition is true, I will execute this statement. And yeah, this is already something why I have this statement block derived from statement, because this then allows us to put a block as a statement here, or you can just have one specific statement. Okay, and when we execute a while, but executing a while is done by having a while loop which keeps evaluating the condition. And yeah, while that's true, it will execute the corresponding statement. Then we will need an if then else. With a boolean expression that we are testing, and two statements, and one of them is going to be executed depending on whether the condition is true or not. And for the else case, I will have the default value null pointer so that we can also use this just as an if-then without an else. Okay, if condition evaluate. Okay. One class for, up here I have one class for writing text, but we will also need to write values, integer values, and yeah, I will just have a different class for that right now. Okay. Blocks, writing text, writing ints, while, if then else. Yeah, I will make another class for reading values. Which will have a location value. And yeah, this is where the location this location value is supposed to define where that red value is going to be stored. Okay, when we execute that, we read a temp value, and then we will set the L value to that temp variable. We will need some another statement for storing something we evaluate the expression, and then we set the L value to that value. Okay. Yeah, here we might want to include just everything. Okay. Now, as I said, I want this main to basically just take some of these classes, build a program from them, and then run that as a test, just to see if these classes all work. Okay, for compiling CPP files. I've often shown that how to do that in a makefile. So to generate a .o from a .cpp, we just use G++ with the output file as output file and the input file as compile file. And to link in the end. Since we haven't really put any code in the okay, here we've put some code, so in this make file we'll need the base.o also, but all the others don't have any code in them, so okay. So we will have a block. And we will build our program from that block. Then we will execute the program and then delete the program again. Yeah, maybe just put something like statement write using hello world. Ever since I've seen that video from Kevlin Henny, I cannot help but put this comma here. Yeah, I think this looks like it should almost work. Actually, this should work because we aren't doing anything with L values yet, and L values were the only ones where we would have problems left. Yeah, let's just try and run this. Okay, this is our directory. Set in lvalue.h. Oh, this should not be an arithmetic expression, it's a location value. Wow, it compiled on the first try. So yeah, let's see. It says hello world. I'm amazed. Just one little error here and it already works. So yeah, maybe a \n there. Okay, yeah, this is pretty cool. So so what we are doing now, of course, is we are building a program on the stack, and then we say we want to execute that, and yeah, the statement block then just executes every statement it has. Right now it only has this statement hello world. We could also put another statement in there. Now it executes both of them. Okay, maybe have something let's write an integer. Okay, this stuff like this can become a bit mind-boggling because you already see I want to write something, and the thing that I want to write is an integer, and now that integer must come from somewhere, and it can only come from an arithmetic expression, so now we need to build an arithmetic expression. Yep. And this must be allocated, hello world, and 5. I will just put an \n down here. New arithmetic expression plus okay, let's calculate 5 plus 7. You know, now the integer that we are printing is the result of a plus with 5 and 7 as the things that we add together. And 5 plus 7 is 12. That is correct. Okay, now when we talk about location values, right now we only have variables, and a variable only has a name, and you cannot store something in a name, right? So so what you would do in practice, I mean, we could just have something like standard map for standard string to int. Where we would say that setting a value would put the value into that map at the position of the name, and then when we evaluate it, when we evaluate a variable, then we get that value from the map. I would make this a static field here. Then we would have to put it in here. Okay. Now l-value CPP also contains some code, so now we need to put l-value.o into the thing here. Okay, now it compiles. Let's test this. Now we don't write the integer directly. We could first create a location value. In good programming tradition, I will just call it foo, and statement assign. Now I will assign to this L value the result of 5 plus 7, and then the next thing write int L, because L values are arithmetic expressions. So this should work, but I will change the number here just so that, you see that we just don't get the same 12 from before. I don't have the constructor for the base class. Okay, let's try again. That doesn't look good. I know what's wrong here, I think. Is it? I put the same location value in two different places, and both of them will try to delete this. Will try to delete it. So this could just be a double free. Yes. Okay. Yeah, that makes sense. I had tried to use the same location value variable in two different places, and yeah, then this statement deleted the location value variable object, and then this one also tried to delete the location value variable object. Okay, and yeah, that crashed the program. Okay, but now let's think about a case. Maybe you want to add multi-threading to your programming language later. So, or maybe just some other way of two different paths where you want to just have separate separate values for the same variables. Like I don't know, if you're writing a scripting language and you run one script and you run another script, then you don't want the variables from the first execution to remain to be left over when you run the second script or something like that. So yeah, this approach of having this one map and have this basically a global variable that will be reused all the time, that's just not so great style. So what you would do in reality is you would have another class here, and yeah, a very common name for such a class would be context. So and then you just store. This is then not static, so you can have multiple of these contexts and run different scripts on different contexts, for example, and do that in different threads, so that they don't break each other's data. You know, let's say you have two scripts and both of them use a variable named foo, and yeah, if you just use one global map for this, then you might set foo here, then you set foo there. Now you read foo here, and yeah, now you're reading the one from here and not from here. So in reality, you would want to have two separate contexts and run this script on the first context and the other script on the second context, and then they just cannot disturb each other. Okay, good. And yeah, now just have constructor, destructor, doesn't matter much. And now you will just have this context as parameter to all these functions here. So statements get a context, Boolean expressions get a context, all these evaluate functions get a context. Here you pass the context into these recursive calls. Okay. Okay, for constants, of course, you don't need the context. True and false also don't need this context. But yeah, here this stuff here in this location value things, here you really need the context. So now you are taking the you store the value not directly in some global context. You are now using this context that you are getting from your parameter. You're always passing it down. Here you can also see this here really makes more sense now that you have this context explicitly, because yeah, without such a context, this execute wouldn't even change anything. So technically this while should never terminate, because the condition should not change at any time. And this whole deal with storing something in a global variable, that was just a hack to circumvent this problem, you know. Okay. And yeah, now here we've built the program. Now we need to create a context. Now we run the program on this context, and at the end we delete the context and the program. Okay. Okay, this is looking pretty good. So okay, so I think you can now see what we are doing. We have now all these classes for all these primitive things that you would have in a programming language. You know, like addition and multiplication and if then else. And with these classes, we build a model of our program on the heap. So this is like a hard-coded abstract syntax tree. And yeah, in the next video, we will use these classes to really build the abstract syntax tree using Bison. So we will have a parser generated by Bison, which will read a source code and then build a abstract syntax tree like this, but based on the source code it's reading. So then you have an object like this here, this program object, which you can then execute on a context. And yeah, that's what we will have then is called an interpreter for our programming language. You know, like Python is an interpreted language. In the next steps, of course, then we want to translate that to assembler. But yeah, the next step after this is really a parser in Bison, which will build this abstract syntax tree dynamically based on a program as that it's reading and not hard-coded like here. Okay, so absolutely don't miss that. That's going to be the absolute center, the highlight of this video series, because yeah, the parsing is really the hard part of writing a compiler or an interpreter. So that's going to be absolutely the most interesting part of this video series. So yeah, if you liked this video, like it, share it, subscribe, and see you next time.